Good morning to everyone. Myself K. Vijay Kumar. I'm from Mechanical Engineering. Today my presentation on an impact oscillator with finite time collision. Introduction to impact oscillator with finite time collisions. Impact oscillators are systems that undergo repeated impacts with a boundary. Finite time collisions in impact oscillators involve a specific duration for each collision event. These systems exhibit complex behavior due to the discrete nature of collisions. In impact linear impact 38 cost frequency ratio NN 0246, the graph defines the number 0246 and 123. Finite collisions and impact oscillator with involve a specific duration for each collision event. To know we about the oscillators are the systems that undergo within impacts with a boundary describes the nature of the collisions. They exhibit complex behavior to describe the nature of the collisions. Next, characteristics of impact oscillator dynamics. The dynamics of impact oscillators are highly nonlinear. Time of first impact frequency ratio, distance, time of first impact distance frequency ratio. Here we see the images and the sign are sign q and the ratios are 0 1 2 3 0 1. Time of first linear is equal to 0246. And clearly we do know about the dynamics of impact oscillators are highly nonlinear. And energy deception plays a crucial role in the system behavior. The collision's duration affects overall the dynamics and stability of the system. Next, modeling finite time collisions in impact oscillators. Mathematical models for impact oscillators with finite time collisions involve capturing the contact force during collisions. The impact duration is a key parameter that influences the system response. Various numerical methods can be employed to simulate and analyze the impact oscillator dynamics. Major steps in finite volume method discretes the physical domain and identify governing equations and BCS. Integrate over the control volume. Interpolate approximate the differential terms. Calculate unknown using numerical matrix methods. Governing equations. Integrate over the control volume. Average value of S over ACV. Control volume central point. Major steps in finite volume method FVM to know the WPES and FP. In mathematical conditions, we know about the impact oscillators and finite the collisions during the force during collisions. Next, impact oscillator behavior with varying collisions durations. Shorter collision durations can lead to higher frequency oscillations. To the longer collision durations may result is more significant energy dissipation. To know the various methods and resonance transmissibility. Natural frequency are made into input input frequency. Distorted resonance when the gamma equal to damping coefficient transmissibility frequency ratio. Longer collision durations may result in more significant energy dissipation. The impact duration parameter can be tuned into controls the system response and stability. Experimental studies on impact oscillators with finite time collisions. Experimental setups can be designed to validate theoretical models of impact oscillators. Measurement techniques such as accelerometers and strain gauges are used to capture the system's responses. Experimental data can provide insights into the impact dynamics and validate numerical simulations. To know various about the design to validate theoretical models of impact oscillators. Here we know the graph and 0.5, 1.0, 1.5 meters and graph shown as experimental data can provide the insights into the dynamics and numerical simulations. Next, applications of impact oscillators with finite time collisions. Impact oscillators with finite the collisions fine and applications vibration energy harvesting systems. They are used in impacting testing structure health monitoring applications. Here we see the examples: Lagrangian dynamics, lateral trajectory, stochastic observations, neural spikes, right boundary, left boundary, time, latent state, potential. Here we see the A and B examples. In B examples, latent state, stochastic, stochastic observations, POX, and the lines are the different examples in the structural health monitoring application. The controllability of collision duration makes the system suitable for various engineering applications. Here the time collisions are Lagrangian dynamics, latent trajectories, stochastic observations, neural spikes. Here the stability analysis of impact oscillators with finite time collisions. Stability analysis involves examining the system's responses to perturbations, perturbations. Bifurcation analysis can reveal the different nodes of behavior impact oscillators. The impact of duration parameter can affect the stability boundaries of the system. Infinite Finite slope analysis, soil element of unit length, failure surface, effect of water table, soil element of unit length, failure surface, effect to normal surface. Here we do the example of two diagrams: infinite slope analysis, effect of water table. Here the infinite slope analysis, soil element of unit length, failure surface, and the second example is effect of water table, soil element of unit length, failure surface, effective normal stresses. Next, control strategies of for impact oscillator with finite time collisions. Control methods such as feedback control can be employed to stabilize impact oscillators. Optimal control strategies can be designed to regulate the system's response and energy dissipation. Adaptive control techniques can adjust the impact duration in real time for improved performance. Here we know the examples and solution breaks. Solution 1, solution 2. The mainly two graphs are given. Graphs can be ratio 0, 5, 10, or vertical is equal to 0, 5, 10, 15, 20, and the horizontal is 0. 0.1, 0. 0, 0.1, 0. 0, 0.15, 0.15. We know the control techniques can adjust the impact duration in real time for improved performance, and control methods such as feedback and can be employed to stabilize impact oscillators. And next one, challenges and future directions in impact oscillators research. Understanding the impact of non-linearities of system behavior remains a challenge in impact oscillator research. Developing robust state control strategies for practical applications is an ongoing area of research. Future research may focus on integrating impact oscillators with other dynamic for enhanced functionality. Because we know that developing robust control strategies for practical applications and is ongoing area of research. Future research may focus on integrating impact oscillator with dynamic system for enhanced functionality. Here we know that tracking efforts were mainly given the two graphs times and proposed method TBLF. One shows graph times of 0, 50, 100, 150, 200, 0 to max 300, and the times are point 4 minus 0.42 plus zero point 0.4. And next one, last one, the conclusion. Impact oscillators with finite time collisions can exhibit rich dynamics and complex behaviors perfectly inelastic collisions. Since the objects stick together, they share the same velocity after the collision. Before collision and after collision. Before collision m1 v1 by v2 and m2. After collision m1 plus m2 equal to v dot fb. The collision duration parameter plays a crucial role in sharp shaping the system response, and continuous research in this field can lead to advancements in vibration control and energy harvesting techniques in the soil. Thank you.